Hi guys, welcome to the first tutorial of NCEA Level 2 Physics, Electricity and Electromagnetism. Today I'm going to be going through question 1 of the 2016 NCEA paper. Let's go. Question 1, DC. A car radio can be modeled by the use of resistors. One resistor can be used to model the radio receiver. Two different size resistors can be used to model two different size speakers. The resistance of the radio receiver is 10 ohms and the resistor of the small speaker is 80 ohms. The current from the car battery is 0.3 amps. Calculate the voltage across the radio receiver. So that is this here. This is pretty easy. It's just one step, I think. If you look on your formula sheet, the voltage will equal the current times the resistance. It's V equals current times the resistance. The current is the 0.3 amps, so 0.3 times the resistance, which is 10 ohms here, times 10. So that will equal V equals 3 volts. Okay, very easy achieved question. Next. Calculate the current passing through speaker A. Okay, so first of all, our current equation is just V equals IR rearranged, so I equals V over R. Now, we know that the resistance is 80, so, but our voltage, because this is a series circuit, it's just going to be, we know that this is 3 volts, this radio receiver, because that's what we calculated. So that means this voltage just has to be 12 minus 3, because they share the voltages. So the voltage equals 12 minus 3, that equals 9 volts. So we can put 9 here. So our current will equal 0.113 amps, and if we want to round it, we can to I equals 0.11 amps to two significant figures. Alright, this is actually a merit question. If you have the correct answer of 0.113 amps, you don't even need to round it. So this is merit. For achieved, you have correctly calculated the voltage being 9 volts, so yeah. Or you have an incorrect current due to incorrect voltage. I don't know, this is achieved. Okay. Next, speaker B uses more power than speaker A. Compare the resistance of speaker B, so the resistance of speaker B with the resistance of speaker A. No calculations are required. So we don't have to do any calculations. You can if you want, but it's not required. So when we think of resistance, okay, it's this formula here. So we're worried about the voltage and the current. Now, we're only focused on speaker A and speaker B. Now, we notice that the voltage will be the same. Okay, the voltage stays the same across both speakers. However, we'll know that speaker B will have less resistance because there's more current passing through. Because if we wanted to find the current for speaker B, it's just 0.3 minus what we calculated for speaker A, because they will share the current. The current's going to go, it's going to flow through there, and it's going to flow through there. So this will get more current. There's going to be more current, which means there's going to be less resistance, because the voltage stays the same. So, we can write something like this. I'm just going to go. So, what can we do? writing something like this. The voltage across speaker A and B is the same. Speaker A has more. Actually, we can write speaker B, not speaker A. Speaker B has more current flowing through. This means its resistance is less. Alright, that's it. That's all we need. No calculation required. So, for merit, you need to have the correct answer with both correct reasons. So, we're talking the voltage being the same, and speaker B has more current flowing through. This means its resistance is less, so more current. So all through. Merit. For achieved, it's just correct answer with one reason. So that's saying like, the resistance is less because there's more current passing through, or the resistance is less because, well, there's not really another reason, is there? Or you could back it up with here is achieved. Just a correct answer backed with one correct reason. Alright. A 12-volt car battery can be connected to a car's headlight. One of the bulbs in the car's headlight is rated 12 volts. It's 60 watts. A normal household bulb is rated 240 volts and 60 watts and is connected to this 240 volt household supply. Carry out calculations, so now we've got to carry out calculations to explain which bulb, the car's headlight or a normal household bulb, has more current passing through it. Okay, well, we can just do our simple current calculations. So we know that P equals IV, so I equals P divided by V. Yep. So let's just break this into two parts. We're gonna do the household here, household bulb, and we'll do the car light here. Alright, household bulb, it's I equals the power, which is 60 divided by 240. Oh, what's going on here? So that will equal 60 divided by 240 is 0.25 amps. Alright, now the car light, I'm just going to put another thing. I equals 60 divided by 12, so I equals 5 amps. So we can see that there's more current flowing through the car battery. Now, so we could say something like, there is more current passing through the car light. Okay, part II. Discuss how the brightness, so the brightness is basically just a fancy word for power. Power of the car's headlight bulb compares with that of the normal household bulb. Assume both bulbs are the same type. Okay, now one thing we notice is that they both have the exact same power. Okay, they're both 60 watts, 60 and 60. So let's just start off with writing something like both bulbs have the same power. So both bulbs will shine with the same brightness. Okay? That is literally all you need, I think. You could also talk about brightness depending on the voltage and current, and the product of the voltage and current is the same. Okay? So if we also do brightness depends on voltage and current and product, which is like the product means multiplied of voltage and current is the same. You don't have to have that, that's just optional, so I'll write or. Okay? Any of those reasons are good. I can prove this to you. So if we do the voltage times the current, so we can see that the car's voltage is 12 and the car's current is 5. That equals 60. So this is the car. And we can see the voltage of the household is 240. And the current is 0.25. And that also gives 60. So these two are the same. Same. Okay, that's that question done. This is an excellence question, this part I and II. So, for excellence, you need to have a full answer, so it has to be comprehensive. You have to have the two correct units, so these two. You also need to have a statement on there's more current passing through the car light. And then you also need to discuss that both the bulbs will have the same power, and you need to show that power relationship with brightness. So you also need to have this bit right or this bit right, and that will get you an excellence. For merit, you just need to have the correct current through the car battery and household lamp, and you need to have both lamps have the same brightness. So you don't even need this. If you get this statement wrong, I think you miss out on excellence. Or it says, or you just have a correct answer to part II. So just like, just having this is merit. Or you have the correct current through the car battery. So this is also merit. And achieved is just any one of those three. So correct current from the battery or correct current through the household lamp. Or both lamps have the same brightness. So correct current from the battery. So literally just one of these is achieved, any one. Okay, and that is question 1 done. Any questions, just leave a message. I will cover question 2 soon. Cheers.